Here's one question a lot of people have about evolution. Since evolution through natural selection depends on the development of new traits, and that means that the information in the genome must increase, where does that information come from? For that matter, what actually is information? The scientific definition of information is the reduction in the amount of uncertainty of the state of a system. In other words, to know more about a system, to have less uncertainty about it, you need to obtain information. This is quantifiable. If the amount of uncertainty has been cut in half, then 1 bit of information has been obtained. A bit, or binary digit, is simply a 1 or a 0, and it can answer any question to which there are only 2 possibilities, yes or no, heads or tails, male or female, and so on. You just assign one value to a 1, and the other is the 0, so maybe a 1 in a database means the person is male, and 0 means she's female. Ever played the game 20 Questions? A series of yes or no questions can very quickly identify anything the other person might be thinking about, and each question is a bit. So in 20 questions, your goal is to narrow down the entire universe to whatever it is they're thinking about by obtaining less than 20 bits of information. The guy who first worked this out is named Claude Shannon, and his theory, information theory, is also known as Shannon theory as a result. Shannon defined 3 types of content: information, redundancy, and noise. Information is that which actually decreases uncertainty. Redundancy does not decrease uncertainty because either the information is previously known to the recipient or is included elsewhere in the message. Noise is just noise. Consider these 2 sentences. I have a dog. I have a beagle. Both of these contain information, since they both decrease uncertainty. But what if we flip them around? Then it's only the first sentence that contains information. The second sentence no longer contains information, since the fact that you have a dog is included in the statement about you having a beagle. So it's not information anymore, it's redundancy. Noise would just be complete gibberish. Flamborghini Zixel Halloo is noise. So is, my left carbuncle's flavor is a heavy shade of penguin. Neither of these impart information, and never could. So how does evolution increase information? Let's look at an example. Nylonase is an enzyme that allows a certain strain of flavobacteria to digest the byproducts of nylon manufacturing. It didn't always have it. It was created by a new gene that increased the complexity of its host and gave the organism new information. This bacteria, in less than a few decades, evolved the ability to digest nylon byproducts, which didn't even exist before. Look at this. This is the exact amino acid sequence of the original digestion gene. There was a gene duplication event that made a copy of this gene, which has no effect except that one copy could mutate freely. No new information was actually created at this point. According to Shannon theory, this is just redundancy, since it's a copy of a gene that exists elsewhere. But the next thing that happened wasn't just any old mutation, it was a frame shift, the most dramatic kind of mutation there is. It affects every single amino acid from the point of the frame shift on. You see, amino acids are formed by every 3 nucleotides, so if you insert a nucleotide, which is what this mutation did, it changes not only the amino acid it inserted itself into, but every single one thereafter. There are 427 amino acids in the original gene. The frame shift took place after the 33rd amino acid, altering over 92% of the gene's information. That's 92% of it gone, finito, kaput. But remember, this is not a loss of information because this gene is a copy. But the frame shift also added a new sequence to the gene, 392 amino acids all total. Just like that! Brand new information telling the bacteria how to digest these nylon byproducts. Not only that, but it made a new start codon at the insertion point, which means that the new sequence the mutation created is an entire gene in and of itself. The first 33 amino acids are no longer part of the gene, so the new gene is 100% brand new. Let's do the math to see how much information was created by this single mutation. There are 4 nucleotides all total. To see how much information they take, we use the formula from Shannon theory, the log base 2 of the number of possibilities, in this case 4. That equals 2 bits. Each amino acid is coded by 3 nucleotides, so that's 6 bits of information for every amino acid. Since the mutation generated a sequence of 392 amino acids, that means that this single mutation event added 2,352 bits of information to the bacteria's genome. 2,352 bits of information that absolutely was not there before. This adaptation has actually been discovered to have happened several different times, in several different ways. This was far from the only way to develop this feature. In addition, Richard Linsky witnessed a strain of E. coli in his lab develop the ability to digest citrate in much the same fashion. This is happening in your own body too. Scientists have found that the genes that work together to make the hemoglobin in your blood all developed from a single ancestral gene, with gene duplication events followed by various mutations, all of which increased their information and led to our very complex system of hemoglobin. Another has been identified in melanoma patients, where a frameshift mutation results in a peptide capable of attacking tumors. In fact, scientists have discovered over 400 such new genes in the human genome. So the next time you hear someone claim that evolution cannot increase information, you'll know better. And if they stubbornly cling to this incorrect notion, just ask them if they can tell you what the scientific definition of information is and what the three kinds of content are. You already know the answer to these questions. If they can't answer them, then they aren't in any way qualified to say what is information and what isn't, and you'll know not to listen to them about anything else either.